The last topic, let's talk about how to solve exponential equations. So let's look at the principle how to solve exponential equation. Solving all the exponential equation, we use this principle. If two exponential form, okay, with the same base, they are equal, and then that indicate the two exponents must be equal. All right, so that's just telling us if given us an exponential equation, we try to, let both sides of the equation write as exponential form with the same base, and then we can let the two exponents are equal. So now let's look at example. 3 raised to x plus 1 power equals 81. So 3 raised to x plus 1 power, this is already exponential form with the growth factor 3. So right hand side 81, we also need to write to equivalent exponential form with the exponents with 3 as the growth factor, right? And then so the question we need to ask ourselves is 81 is 3 raised to how many power? So that's 4, right? 3 times 3, 9, right? 9 times 3, 27. 27 times another 3, that's 81. So 81 we can rewrite as 3 raised to the 4th power. Now we can apply that principle, right? Two exponential with the same base, they're equal. So we can let two exponents set to equal. So we convert solving an exponential equation into solving a linear equation, and then we can easily solve x equals 3. All right, let's try another one. 2 raised to 2x plus 1 power equals a raised to x plus 3 power. So from the first glance, we already have the exponential form. Okay, both sides of the equation, they're exponential form. But the problem is the two base, okay, growth factor, they're not the same. Okay, so we have to find a way to rewrite it so that they can have the same base. And then if you notice, 2 to the 2nd power, that's 4, right? 2 to the 3rd power equals 8. And then we can rewrite as 4, that's 2 to the 2nd power, right? And then to another 2x minus 1 power. 8, we can write 2 to the 3rd power, and then raise another x plus 3 power. Raise a power to a power, we multiply two exponents, right? So now they have the same factor, right? Growth factor. And then we can derive. Okay, let me just write one more step, okay? So that's 2 raised to the 2 exponents multiply. 2 times 2x minus 1 in the parentheses. And the right hand side is 2 raised to the 3 times x plus 3 in the parentheses. So now we can let the two exponents are equal since two exponential form, they have the same base. So we got 2 times 2x minus 1 equals 3 times x plus 3. And then solving this linear equation. Okay, distributive property, eliminate parentheses. We got a 4x minus 2, that's left hand side. Right hand side is 3x plus 9. And then both sides subtract 3x and then plus 2, and then we can solve x equals 11. Okay, so that's the solution for first two example. All right, and then let's try another one. Solve this exponential equation. So left hand side, nothing, we can simplify, right? We already exponential form with the base natural e. So right hand side we have to simplify. So e to the x power raised another 2nd power, raise a power to power and multiply two exponents. So that's simplified as e to the 2x. And then 1 over, whenever you see 1 over, we can rewrite e to the negative 3 power, right? Reciprocal, that means negative sign on exponents. And then two exponential multiply, we can add the two exponents. So now we can let the two sides of the equation exponents are equal. So we convert solving exponential equation to solving the quadratic equation. So that's negative x squared equals 2x minus 3. And then we add x squared on both sides. We got x squared plus 2x minus 3 equal to 0. And then we can solve by factoring method. X plus 3 times x minus 1 equal to 0. So we can solve x equals negative 3 or x equals positive 1. Okay, so we got a two solution. Either x equals negative 3 or x equals positive 1. And the last example is a word problem, okay, using exponential function. It says between 9 o'clock p.m. and 10 o'clock p.m., cars arrive at Burger King drive-thru at a rate of 12 cars per hour, which is converted to 0.2 cars per minute. Right, the following formula from statistics can be used to determine the probability that a car will arrive within t minutes of 9 o'clock p.m. So this is a model, which is exponential functions model. Okay, so we have 4 questions. A, determine probability a car will arrive within 5 minutes of 9 o'clock p.m. So that means t equals 5, right? We plug in x by 5 and then use the graphic calculator to solving this equation. And then we can get f of 5 approximately equals 0.63212. So when you evaluate exponential in the graphic calculator, okay, you need to use the caret key represent exponential. For example, 2 raised to the 5th power. In the calculator, you need to press 2 and then caret key and then 5 and then press enter. Okay. And then for the natural E, I think there is a button for the natural E. E to the x power, you can press second length, okay, to evaluate E to the certain power. So in this case, you press 1 minus, okay, we enter this equation in the graphic calculator, okay, so 1 minus, and then second length, okay, you press the button second, and then press the button ln, that's length, and then to the negative 1 power, right, negative 0.2 times 5, that's negative 1 power, and then close parentheses, okay, negative 1 power, and then enter, you got this answer, 0.63212. Okay, you can try. I don't have graphic calculator emulator on the iPad, but this is the command you should put into the calculator. All right. And then the question B, determine probability the car will arrive within 30 minutes. So replace t by 30. Okay, do the same way. And then it's 1 minus, you press second length, and then on the calculator it appears as e raised to and parentheses, right? And then you put what? Negative 0.2 times 30, that's negative 6 power, right? So 1 minus second length, and then e to the negative 6 power, close parentheses. And then we got like a 0.997, okay? Approximately 0.9975. And then C, graph the function using your graphing utility. So you enter the function, okay, use y equals, and then you can graph the function, okay, which is in the next slides. Okay, you can set up the rectangular coordinate system using the zoom or using the window. Okay, the window x minimal set to 0, x maximal you can set to 30, and then y minimum you set to 0, y maximum you set to 1. Why? Because this function is a probability function, so probability smallest value is 0, highest value gonna be 1. Okay, that's for the y. For the x, after we evaluate it, okay, the time, right, the minimum value is 0. And then when we plug in 30, we already see the probability is 0.9975, right, very high. So that's why you can change the x maximum to any other number, but 30 is already can see majority of the graph because it's almost reached 1. All right, so that's the graphing part. And then the number d, what value does function approach as t increase without bound in the positive direction? So if you look at this graph, okay, as t approaches to positive infinity, and then the curve will approach the 1. Okay, so probability will approach 1. So that means as the time increase, and then the car stop by the Burger King drive-through is almost certain. Okay, almost 100%. So that's the last question, right? So this is the section 6.3. Right, we finished today.